Hi, pals. Today we are going to be looking at square roots of diverse kinds of numbers. So you're going to be looking at how to get the square root of almost all kinds of numbers. I mean, every kind of number you can imagine using this very tabular method. Now, this method is not limited. It's not limited like the tabular method that involves the use of the product of prime factors. Now, this method could work for the square root of any kind of numbers. Now, if you look at this, get the square root of 3136. That's 3136. Now, how do we get the square root of this very number? Now, we could use the product of prime factors method. Let's see that. Let's see if that method could work for this. But this very method we're talking about could work for any kind of number, regardless of if it's a prime number or not a prime number. So if you look at this, the first thing I'm going to do is to draw your table like this. You draw your table and then you get the product of the prime factors. That's 3136. You end up using your prime numbers 2, 3, 5, 7, and so on and so forth. And that's what you're going to do. So first of all, 2 can go in this number. And that's why in the previous expositions we've worked on proving 2, proving 3, proving divisibility of numbers. You have to have a good knowledge of all that for you to understand this. So first, you're going to be dividing this. 2 in 3 is 1. Remember 1. 2 in 11 is 5, 10. Remember 1. 2 in 13 is 6, 12. Remember 1. 2 in 16 is 8. 2 goes again. 2 in 1 is 0. Remember 1. 2 in 15 is 7, 14. Remember 1. 2 in 16 is 8. 2 in 8 is 4. 2 goes again. 2 in 7 is 36. Remember 1. 2 in 18 is 9. 2 in 4 is 2. 2 goes again. 2 in 3 is 1. Remember 1. 2 in 19 is 9. 18. Remember 1. 2 in 12 is 6. 2 goes again. 2 in 1 is 0. Remember 1. 2 in 19 is 9. 18. Remember 1. 2 in 16 is 8. Use your 2 again. 2 in 9 is 4. Remember 1. 2 in 18 is 9. Then the next thing we do is to use our 7. 7 is the next number that can go. 7 in this and 7. And 7 in 7 is 1. Now, as you can see, there's a product of prime factor method. You just have to know your list of prime factors and understand proving divisibility of numbers. So the next thing you do is to state out all this. And when you state out all this, you take them because when you talk about square root, you're talking about the root of two numbers, that is square of numbers. So that's going to be 2 times 2, 1, 2, 3, 4, 5, 6, times 2, 3, 4, 5, 6, times 7 times 7. Now the square root of this. So we're going to be taking two numbers at once. We'll take 1, 2 equal numbers, 1, 2 equal numbers, 1, as I'll call them square root 1. So what do we have here? 2 times 2, 4, 4 times 2, 8, 8 times 7 is 56. Now, what's our answer? Whenever you're working on root of numbers, even roots, square root, fourth root, sixth root, and so on and so forth, your answer would always be in plus or minus, because plus 56 times plus 56 will give us 3136. Minus 56 times minus 56 will give us 3136. So all even roots will surely give you plus or minus when you get your final result. So that's just that for this method. But we're going to be looking at a couple of more examples whereby you can use this kind of repeated multiplication method, because we're going to be dealing with prime numbers coming together to give birth to different kind of squares. So we're going to be getting root for such numbers. So there's a method we can use to get the square root of all kinds of numbers. Now, this very method could be used to get the square root of regular numbers like this one we just did here. And we can also use it to get the square root of irregular numbers that are prime in nature, let's say prime numbers and so on and so forth, all kind of numbers. So we're going to be using that very method to get this first, to get the square root of this. Now, before we use that very method, you have to understand basic things, basic arithmetical operations, addition, subtraction of numbers, and so on and so forth, and division also. So now let's do that very method. Now this is what you're going to do first. You write out the number square root of this, 3136. You write this out, plus or minus, don't forget that. Now 3136 Now, where's the point? This is a whole number. There's no point stated. So if there's no point stated, it means the point will be at the back of this number. The point is going to be here. Now, since you're talking about square root simply means we're dealing with numbers that come in twos. I mean, double numbers. That's double digit, 5 and 5 and, 6 and 6 and so on and so forth. All kinds of numbers. It could be 3 and 5. But when you talk about square means two things. So it could be either perfect square or imperfect square. Perfect square simply means two equal numbers, come together, while imperfect square means two different numbers come together. But when you talk about square, it has to be 2 digits at a time. If it's a cube, 3 digits at a time. So now our pointers here, one number is close to the point, 6. So the next thing we're going to do is to share them 2, 3 and 6 together. Next, 3 and 1. So what do we do next? The next thing we do is to draw our table. We're going to do this. We draw our table like this. So that's going to be 3. We're going to share them. That's 31. And then 36. My pointers here. 2 zeros like this. You just have 2 zeros. You share the zeros also 2, 2, 2, 2. Everything we do here is in twos. The whole numbers 2, 2. The decimal fractions 2, 2. So what do we do here first? Since you're working on the first number is 31. So we're going to be checking the table. There's a table up here. As you can see, there's a table right up here. Now this table here is a table that shows a list of perfect square from 0 to 100. As you can see, this 0 times 0, 0, 1 times 1, 1, 2 times 2, 4, 3 times 3, 9, 4 times 4, 16, and so on and so forth, down to 10 times 10, 100. So we're going to check 31. Do we have 31 among this perfect square? This 0, no, 1, 4, 9, 16, 25. 36 is bigger than 31. What do? We go back to 25. Go back to 25. So we're going to be taking 25. So what are two numbers that came together, or that come together, to give birth to 25? That's 5 and 5. So put our 5 here. We put our 5 here. Now what do we do here? With times, after we're done multiplying, just like long division method, you subtract, you bring down. That's the next thing we do. So 5 times 5 is 25. Then we subtract 31 minus 25 is 6. After you're done with that, the next thing we do is to bring down. We bring down the 3 and 6, the next couple. You bring them down, 6 and 3, that's 6, 3, 6. So you add up your two factors together, 5 and 5. That's 5 plus 5 is 10. And that is 10 right here. Now you do that after you're brought down. Now let me show you the steps. Now these are the steps we take whenever you solve this. Whenever you're using this method, the first thing you have to do is to bring down. After you have brought down, the next thing to do is to get the factors. And after you've done that, the next thing to do is to multiply. And after that, you subtract. And after that, you add together. Then you repeat the cycle. You repeat the cycle. You bring down. You get the factors. You multiply. You subtract. Then you add up. So now we've done this. Now we brought down. The next thing you're going to do now is to bring down. We've done the bring down. So the next thing to do is to get the factors. So you ask yourself a question: what will I add here and also add here? That once I do that, when I multiply them, I will get 636. Now if I add my 1 and 1 to this, if I add 1 here and add 1 here, it will become 101 times 1. 101 times 1 is not up to 636. If I add 2 here and put 2 here, 2 times 102, that will give me 102 times 2. That will give me 204. It's not up to 36. If I try 3 and 3, 103 times 3 is not up to 636. If I put 4 and 4, 104 times 4, let's try that out first. 104 times 4. If I put my 4 here, whatever you're going to put has to be equal numbers. If you put your 4 here, it has to be 4. 5 and 5, 6 and 6, and so on and so forth. So 4 times 4 is 16. 6, keep your 1. 4 times 0, 0 plus 1, 1. 4 times 1, 4. This 406 is not up to 636. 5 and 5, let's try out 5 and 5. 5 here and 5 here. 105 times 5. 5 times 5, 25. Keep your 2. 5 times 0, 0 plus 2, 2. 5 times 1, 5. 5, 25 is not up to. Let's try 6 and 6. 6 and 6 here. 106 times 6. 6 times 6. 36. I 6, keep your 3. 6 times 0, 0 plus 3, 3. 6 times 1, 6. 636 exactly. Now if you don't get the exact number you're looking for, you can pick something closest to what you're looking for. So now we've gotten what we're looking for. So put your 6 here. Put your 6 here. Don't forget, after bringing down, you get the factors. Now we've gotten the factors. After that, we multiply. 6 times 106 is 636. And after that, After you're done multiplying, the next thing you do is to subtract. And after that, you add 6 plus 106 is 112. So at this point, you're going to stop here. We've gotten what we want. So what's our square root? Our square root is 56 plus or minus. This is an even root. So you're going to be looking at another example. So this time around, you're going to be looking at far more complex examples. You're going to be looking at, you're going to be getting the square root of numbers that are prime in nature. So look at the square root of 531.5. Square root of 531.5. 531.5. Now, what do we do here? Now, the first thing you have to do is to write it out. 531.5. Now, there's a decimal point here. So the next thing we do, don't forget that when we talk about square root, we're talking about, we're talking about twos, as I said already. So the point is here, what are the numbers closest to the point? 1 and 3. So we're talking about two set of numbers. So you take the first two, 1 and 3, that's 3 and 1 here. This one here, just 5. 5 doesn't have a partner. You add 0 to it. 0 and 5, you're done with the whole numbers. So we start with the decimal fraction. 5 is the closest to the point. This 5 and no partner. Add a 0 to it, 50. So now we know what we want, what we're going to be operating with, or you're going to be working with. So draw your table like this. So the first is 0.5, and after that 31, period point, and after that 50. So now, as you can see, the first is 0.5. So you can go check your table. I gave you a table of perfect square up there, where we have 0 times 0, 1 times 1, 2 times 2. So if you check your perfect squares, 0 times 0 is 0, 1 times 1, 1, 2 times 2, 4, 3 times 3, 9. 5 is not a perfect square, so we're going to pick 4, because 5 is not among them, so we're going to pick 4. So 2 and 2 will give us 4. 2 times 2 is 4. And don't forget, as I said, after you have gotten your word, after you have brought down, we brought down 5. Bringing down means to focus on a given pair. So after you've done that, you get the factors, 2 times 2. After that, you multiply. From there, you subtract. And after you've done that, you add 2 plus 2, 4. So what do we do next? We bring down again according to the rule. Bring down your 31. And after you've done that, get the factors. Now this time around, we're not going to be dealing with perfect squares anymore. You ask yourself a question: what will you add to this, and also add to this, that when you multiply, you get 131. Now if I add 2 and 2 here, if I put 2 here, it'll be 42 times 2. 42 times 2 will give me 84. It's not up to 131. If I add 3 here and add 3 here, 43 times 3, that will give me 129. Very close to what I want, but it's not up to it yet. If I add 4 and 4 here, that will be 44 times 4. 44 times 4. That'll give us 176. It's far more than what we're looking for, so we're going to be using the 3. So put 3 here and put 3 here. So after we've gotten our factors, the next thing to do is to multiply according to the rule. This 129. After that, you subtract 1 minus this 2, this 2, so 0 and 0. Then you're done subtracting. The next thing to do is to add. You add the factors. So 3 plus 43 will give us 46. And after that, we're done with the whole numbers. We enter into the decimal fraction. Bring down your 50. Another pair, that is 250. So when you have your 50 here, there's 250 here. So what do we do next? You ask yourself a question: what do I add here and also add it at that when at times, or we end up getting 250. Now if you add a 0 and add a 0 here, that will give us 0. If you add your 1 and add your 1, if you add your 1 and add your 1 here, that will be 461 times 1. That will be 461. It's far more than what we are looking for. So what do we do? What we do next is to use 0. We can't use 1. 0 is what we can use best. So 0 times this will give us 0, 0, 0. Then after that, we subtract. There's 250. Then we add 0 plus 460 is 460. So what do we do next? The next thing we do is, we are done with this. We can then add a couple of zeros. If you feel you can add pairs of zeros, 0, 0, 0, and so on, but I just want to add only one pair. The next thing you bring down again. So what I have there, I have 25,000. So after I brought down the next thing, I'll get the factors. What will I add here and add here? That when I times, I will get this 25,000. So if I add 3 and add 3, that will be 4603 times 3. 4603 times 3. 3 times 3 is 9. 3 times 0 is 0. 3 times 6, 18, to keep your 1. 3 times 4, 12 plus 1, 13. 13,809. It's now up to, we are looking for 25,000. So let's accelerate it. If you add 4 and 4, 4604 times 4, 4 times 4, 16. 4 times 0, 0, 4 times 6, 24. Keep your 2. 4 times 4, 16 plus 2, 18. 18,416. We've almost gotten that. So what do we do next? Let's try 5. 5 and 5. 4, 6. 0, 5 times 5. 25, 2. 6, 30. Keep your 3. 5 times 4, 20 plus this, 23. This is definitely what we are looking for, because if you add your 6, it will be far more than what we are looking for. So you're going to use our 5. P of 5 here. And P of 5 here. We've gotten the factors already. The next thing we do is to multiply. 5 times this. We've seen that already. 33, 2, 3, 0 to 5. The next thing you do is to subtract. After subtracting, 0 minus 5 is not possible. Borrow 4, 10, 9, 10, 9, 10, 5, 7, 9, 1. So after we've done that, the next thing to do, you add them together. 4605 plus 5 is 4610. So at this point, we could decide to just stop here because we have a couple of decimal fractions already. So our answer is 23.05. That's the square root. So square root is plus or minus 23.05. Now let's set the final example. Now look at this. Get the square root of 151.29. Now don't forget, as we said, all even roots, they take plus or minus. Now the first thing we're going to do, as you know, is to write them out. 151.29. Now we have to share them out. So all numbers are the closest to the point. 1 and 2 are the closest to the point. So start grouping them in twos. 5 and 1. Now this one doesn't have a partner. That's where you add your 0 to this. 0 and 1. So we're done with the whole numbers. So decimal fraction. This one already has a pair. 2 and 9. You can add a couple of zeros in twos, in case we have recurring decimals. So the next thing we do is to draw our table. So take them already the way they are grouped. 0, 1, 5, 1, 0.29. Don't forget, you take them in twos because you're talking about square root. You take them in twos. So don't forget the steps. The first thing we have to do is simply bringing down means to focus on a given pair. After that, you get a factor. After you've gotten the factor, you multiply. After you have multiplied, you subtract. After you've done that, you add up. You repeat the cycle. Bring down, get the factors, multiply, subtract, and add, and keep doing the same thing. So the first thing I have to do is to bring down or to focus. So the focus is on 0, 1. Don't forget, the first number you have to check the multiples. You have to check the least of perfect square. Now don't forget the least of perfect square. 0 times 0 is 0. 1 times 1, 1. I think that is that for this. 1 times 1, 1. So that will be 1 and 1. After you've done that, the next thing we do is to multiply. 1 times 1 is 1. After you've done that, we subtract. 1 minus 1, 0. So the next thing we do is to bring down after subtracting. So you bring down your 5 and 1. So after you brought down, I beg your pardon, I've never added. 1 plus 1 is 2. Don't forget, you bring down. After you've brought down, you get the factors. After you've gotten the factors, you multiply, you subtract. After you've done that, you add up. 1 plus 1, 2. After that, you bring down again. 5 and 1. So after you've brought down, the next thing we do now is to get our factors. Now, how do we get our factors? You ask yourself a question. What will I add here? And also when I add it here, when I multiply, I will get this 51. If you add 0 and 0, that will give you 0. If you add 1 and 1, 21 times 1. If you add your 1 and add your 1 here, that will be 21 here times 1. This one doesn't have any business with it. 1 and 1, 21 times 1 is 21. It's not up to 51. If you add your 2 and add your 2, 22 times just this 2 here is 44. If you add a 3 and add your 3, 23 times 3, let's see. 23 times 3. 3 times 3 is 9. 3 times 3 is 69. That's 669. It's far bigger than what we're looking for. That's 51. So we'll go with 2 and 2. So we're going to use 2 here. 2 here. 2 times 22. Is 44. After you're done doing that, we subtract. 51 minus 44 is 7. After that, then we add up just 2 and 22. 1 doesn't have a business, we done 1 already. So 2 plus 22 is 24. So what do we do next? The next thing we're done with the whole numbers, you put your point. The next thing we do, we repeat the cycle, you bring down. Bringing down means to focus on it. So right here we have 729. So you ask yourself a question, what we add here and add here, that when I multiply, I will get 729. If I add my 0 and 0, that will give me 0. It's not possible, it doesn't make sense. If I add my 1 and 1, 241 times 1 will give me 241, it's not up to 729. If I add my 2 and 2, let's try that first. 2 here is 242 times just those 2. That will give us 484. It's not up to 729. Let's try out our 3. 3 and 3. That is 243 times 3. 3 times 3, 9. 3 times 4, 12. 2 keep your 1. 3 times 2, 6 plus 1, 7. 729. Now that's what we're looking for exactly. So we can use it. We're done with that then. So 3 and 3. So 243 after we've done that. So we multiply 3 times 243. That'll give us 729. 729 we subtract. Then we end up having 0. So we're done with that. So what's our final answer? Our final answer is plus or minus 12.3. So as you can see, this very method could work for anything. Any kind of number, we could get the square root of any kind of number. Just bring it on. Any kind of number. This is not restricted, unlike the product of prime factors that is very restricted. So here are a couple of take homes. I'll try these questions out. So you get me the square root of these numbers. The first we have the square root of 30.3601. Don't forget your plus or minus for every kind of even root. Next we have the square root of 1751.315. So at this very point, we're going to be drawing the continue today's exposition. So if you have found this resourceful, please subscribe to this very channel and share this exposition. See you in the next exposition. Thanks.